Question number 8. Number 8 says, the diagram below shows the graph of two functions on the same pair of axes. The lines G and H are perpendicular. So G and H, those are the lines, and they are perpendicular and they meet at P. We're to determine the equation that represents line G. Well, here's what we know. This point here is -6, 0. It's the x-intercept. This point here is 0, 3. It's the y-intercept. Now, in order for you to determine the equation of a line, or the equation of a straight line is defined by the gradient and the y-intercept. The y-intercept C, we know from inspection, C is 3. The line G cuts the y-axis at 3. So C, which is the y-intercept, is 3. What we need now is the gradient. The gradient M is y2 minus y1 over x2 minus x1. y2 is 3 minus y1, which is 0, over x2, which is 0, minus x1, which is -6. So M, the gradient, is 3, and down by the bottom, we have 0 minus -6. Minus is plus, so it's 3 over 6, or a half. The gradient of the line G is a half. The y-intercept is C, so the equation of line G, so this is line G. Line G is y is equal to M, which is a half, x plus C, which is 3. The equation of line G is a half x plus 3. All right, let's go back up and look what's going on. Next, we're asked to determine the equation represented by the line H. Now, here's what we know. We know that the line H and the line G are perpendicular to each other. The gradient of G, M1, is a half. Now, the gradient of H, M2, would be equal to -2 over 1. Now, if two lines are perpendicular to each other, the gradient of one is the negative reciprocal of the gradient of the other. In other words, if I know the gradient of one line, if two lines are perpendicular, and I know the gradient of one, to get the gradient of the other, I invert the gradient and change its sign. If you invert a half, positive a half, and change its sign, it becomes -2 over 1, or simply -2. Now, the line H passes through the point. You can look and see for yourself. It passes through the point 4, 0, which is its x-intercept. That's the line H. So it passes through the point 4, 0. So y is equal to mx plus c. This is x and this is y. Let's put those values in so we can calculate c. y0, m is -2, x is 4 plus c. This is 0 is equal to minus 8 plus c. Negative 8 goes over to the left and becomes positive 8 is equal to c. So the line H is the line y is equal to m, which is minus 2x plus c, which is 8. The line H is the line the line H has equation minus 2x plus 8. Now, the coordinates of P, we're to determine the coordinates of P, and we are to show all working. So we have two lines. We have G and G, which is y is equal to a half x plus 3. So G is y is equal to a half x plus 3. Let's just make double sure. Yes. And we have H, which is y is equal to minus 2x plus 8. This is equation 1. This is equation 2. Ladies, gentlemen, if we want to use calculation to determine the point of intersection of two lines, we must solve the equations for the two lines simultaneously. So y is the same. So what we have is a half x plus 3 is equal to minus 2x plus 8. Both of them are equal to y. I could then multiply the entire equation by 2 to get rid of the fraction. I could then multiply the entire equation by 2 to get rid of the fraction. So it's 2 times a half x plus 2 times 3, 2 times minus 2x plus 2 times 8. I multiply the entire equation by 2. So here I have x plus 6 is equal to minus 4x plus 16. Now I have x plus 4x is equal to 16 minus 6. Positive 6 goes over to the right and become negative. Negative 4x on the left, on the right goes over to the left and become positive. Now I have 5x is equal to 10. Divide both sides by 5, and we have that x is equal to 2. So x at the point P is 2. Let us find out what y is at the point P. So to find out what y is, I simply substitute x is equal to 2 into any of the two original equations. It doesn't matter which one, both of them will give you the same answer. Simply substitute x is equal to 2. Let's put it in equation 1. Y is equal to a half times x, which is 2, plus 3. This is 1. 1 times 1 is 1, plus 3. This is 4. So P is the point, x is 2, and y is 4. Stay with me. Next, we're asked to write finally, this is completing the square. We're asked to write 4x squared minus 24x plus 31 in the form a into x plus h squared plus k. So we're going to use a formula approach. Well, first of all, A is 4, B is minus 24, and C is 31. H is equal to B over 2A. That's minus 24 over 2 times 4. This is minus 24 over 8. So H is equal to minus 3. Let's get K. K is equal to 4AC minus B squared over 4A. K is 4 times 4 times 31 minus 24 squared all over 4 times 4. I would not stress myself. Just put that exactly the way you see it in a calculator and press equal. Sometimes that's when we get things wrong, when we stress ourselves. So let's not stress ourselves. Calculator, fraction, numerator 4 times 31 minus, open bracket, minus 24, close bracket, square, divided by 4 times 4, which is 16. Press equal. This is minus 5. And so 4x squared minus 24x plus 31 is equal to A, which is 4, into x plus h, which is minus 3 square, plus k, which is minus 5. So 4x squared minus 24x plus 31 is 4 into x minus 3 squared minus 5. Next, we are told on the axes below, sketch the graph. All right, so there are no numbers, it's a sketch. But here's what we know. We know that x is equal to minus h is the line of symmetry. So x is equal to minus 3. X is equal to 3 is the line of symmetry. We know that minus hk is the turning point. So the turning point is 3 minus 5. So that's our turning point. We know that the graph cuts the y-axis at 31. 31 is the y-intercept. So maybe we should be going up like this. 5, maybe too big. 5, 10, 15, 20, 25, 30. 31 would be somewhere like there. The minimum is minus 5. So that would be like here, minus 5. 5, 10, 15, 20, 25, 30. 1, 2. Let's make that narrower. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. We know that this is the line of symmetry. We know that here is where we have the minimum turning point. 3 minus 5. That's the minimum turning point. I guess if we want, we can probably remove this line now. Because after just identifying that point, we don't need it for anything anymore. So we can remove it. All right. Now, we can increase the accuracy of our sketch by finding the x-intercepts. I could do that quickly. That's the values of x for which the function is equal to 0. Let me not do it up there. I do it down here. 4 into x minus 3 squared minus 5 is equal to 0. 4 into x minus 3 squared is equal to 5. X minus 3 squared is equal to 5 over 4. X minus 3 is equal to the square root of 5 over 4. X would be equal to 3 plus or minus the root of 5 over 2. X is equal to 3 plus root of 5 over 2, or x is equal to 3 minus the root of 5 over 2. I didn't need to do this. I'm just doing it to increase my accuracy, the accuracy of my sketch. So it's 3 plus the root of 5 divided by 2, and that is equal to, as a decimal, 4.1. So let us say 4.1 is here. And minus, and this is 1.9. So 1.9 would be about there. And so if I want to draw my graph, I can draw my graph now. I have my x-intercepts. I have the minimum turning point. I have the y-intercept. My graph would look something like this. Turn them at the minimum turning point. So somewhere around here. Too much of a perfectionist, so somewhere around. That's all off of my graph. This is x is equal to 3. My sketch is the sketch of y is equal to 4x squared minus 2, 24x plus 31. Moving on, we're to start the equation, state the equation of the axis of symmetry, which, well, that's easy. We already worked it out already. X is equal to minus h. X is equal to minus 3. Therefore, x is equal to 3 is the axis of symmetry. All right. And that brings us to the end of our question.